Hello, my name is Kelly Swanson, and I'm a citizen scientist, an amateur astrophysicist, and amateur astronomer. I've designed a process I call dark light, utilizing Sir Isaac Newton's formulas from his book Optics. I've posted several videos on the subject, and I wanted to show you what its capabilities are at this point in its fifth generation. So, Newton had described a process by which he used multiple prisms to focus light, and he noticed that beyond black, color reappeared. Beyond pure white, color also reappeared. So it got me thinking that these positive and negative light realms existed outside of the visible spectrum. That was my theory. Well, it is a theory now. And I formed a hypothesis that it could be done given the right amount of light captured. But I didn't know if that light even existed. I didn't know if there was if I was just, barking up the wrong tree. So I decided to go for it. And I started with simple photography and doing this for years on my own as a hobby. I got nowhere. So once I finally created this, it took about 4 years to really get the achromatism to work properly. Achromatism is a process where you focus an amount of light in order to reveal a spectrum. And this process is capable in any photograph taken at any time. I've tested this on old mercury-based photographs. The whole point of it is elemental. When you take an image, you're taking an image of what your eye can visibly see. But at the same time, we live on a planet that we're existing in an oxygen-based environment. So there's energy all around us and processes all around us, but we just take them for granted because we can see right through them. Oxygen is transparent to us. We don't see it. But did you know that you can see it if you focus the light harder and sharper to a precision that is beyond human perception? So, utilizing today's technology and making this process available in just a generic commercial application, I used Adobe Lightroom because of its non-destructive capability. Lightroom doesn't imbue anything. You don't create photos with it. It's not Photoshop. You don't add to anything. What you do is you use it like a photo processor. You develop things. You adjust the light, you adjust the histogram, and it allows you to look inside a photo. Now, yes, you can make photos prettier and you can make them really nice, but that really wasn't my point of doing this. My point was more forensic. I wanted to see inside the photo, like an X-ray or an ultraviolet, but even deeper than that, because I had theorized that there was another spectrum we just did not see because we couldn't. And I believe Sir Isaac Newton in his book Optics came across this phenomenon, which is no longer a phenomenon. And without further ado, I'm going to show you with this supernova remnant that was taken an image of with the Chandra-Xray telescope. X-ray is fun because it shows it can kind of take the same energy picture but deeper. And so, without getting into all the astrophysics and the formulas and stuff, I'm just going to show you, the viewer, how I propose to do this. So, I spent years and 300 different filters coming to a point where I felt comfortable enough to start showing this to the rest of the world. And when you build that many filters, you start to question yourself. It's human. We're human. We're like, whoa, what's that? Can that be real? But then when you start seeing the same thing over and over and over again, it dawns on you that this is actually a thing. And you learn. Your mind expands and you're like, wow, that is so cool. I wonder if anybody else would like to see this. To the normal person who just happens upon one of these images, it looks like a mess. I'm going to show you with the new Pentaluna filter. So the picture itself, this is visible X-ray light from Chandra. What you're looking at is energy waves in and around it. And the components of these energy waves are electromagnetic and all electrical in nature, because they have electrons, protons, muons, baryons, you name it, out there in outer space. And these processes are at huge levels of energy, quantum levels of energy, and beyond, into areas we still don't know yet. But we theorize these things into the quantum and nuclear areas of energy, and we hope, okay, we'll figure it out one day. So, as I was building these filters to see, I just kept seeing more and more and more. And to the point of seeing one item here, and then in a different color frequency, you see another item here. And then things start to take shape, and you're going, okay, hold on. This is what they were talking about. And when a supernova, typically star goes supernova, it can collapse into a black hole. And this is the normal function that occurs. But we've always had this one idea of how a black hole looks because we're biased. We all have seen drawings of black holes that artists, illustrated and said, oh, I imagine this is an artistic impression of what I think a black hole will look. And then it gets picked up, it gets published, it gets pushed around, and then Disney makes a movie called The Black Hole, which enamors millions of children who grow up during that time in the 70s, and we were influenced by it, and we really didn't know what we were looking at, but we thought it was so cool. And it was real, because we were at a point in science where the theory of black holes was taking shape. And the idea of, oh my gosh, there's this black hole that can just suck all life forms. And, when I was growing up, they were saying, oh, if the Earth went in, it would squeeze it as small as a grapefruit. And I thought, wow, that would really suck. Well, that's not necessarily true. There's some theorists out there that still hold on to that adage that everything that a black hole sucks in disappears. And all that's left is Hawking radiation in the form of an event horizon. That's half true, because I've seen it now. With this filter, it can dig down and see deeper than any human has ever seen before. And it leaves behind rotation trails. And yes, see that void in the middle? That's exactly what it is, folks. But do you see the event horizon around it, the red line? So this piece is still functioning. it's still rotating. There are multiple lines and multiple ribbings down on the lower right where things are spinning not just around and around, but horizontally and vertically. So when we get down to these deeper filters, such as the New Vision filter, it looks even more different than it did before. Because when you start to look at things, you're not sure what you're seeing, right? But actually, there's science behind this that shows what occurs, mathematically, like the warping of space-time. But somewhere along the lines, a professor mentioned the term gravitational lensing. And the reason he mentioned it was because during his observations in 1919, during a solar eclipse, he saw the chromosphere around the sun, this bright angle that shines through us, and we see it in our visible light. And he saw a star on the other side, like stars. He could see, and it seemed closer. So he attributed that to a magnification. But really, it's the trick of our own atmosphere, because he wasn't out there in the universe with a satellite and a telescope outside of our atmosphere. But yet he was inside. So we have to remember and always keep in mind that that original observation was taken on our planet versus being out in space with a telescope such as Hubble or the James Webb or Chandra or any of the other new ones like Euclid. So I took all this information into account when I formulated mine, because it's not what you think it is. As a matter of fact, it's nothing anybody's ever seen before, and it's all brand new. As you can see right here in the center, the dark light filter on New Vision starts to look at energy and the waves that it creates. These gravitational waves all focus to the center, but as you can see the arcs on the corners, they form a rectangle. And inside the rectangle is a circle, because they're still spinning. And whether or not that rectangle is actually a square or square is a rectangle, the four sides are being spun on the inside and pulling it downwards. So you end up with pointy corners. So as I was looking through these and going through the filters today with this particular supernova remnant, I came across one that I created that has no name. It has a serial number, because it was one final stage of a filter that I had created. And I knew this was something special, and I've used it several times, and I only use it for certain hard to see objects, like this one here. Because the other ones, as you can see, they'll show you only so much. And when you work with these, you have to realize your own human limitations, such as the new Bright X. This shows you energy flowing around like liquid, just the same way a swimming pool would float, and if you dropped some colored dye in there, you would see it float around and move. Well, in the low gravity world of our universe, energy flows like fluids, and it's this dynamic that we are still grappling with as a human species. I mean, we've only been at this for less than a couple hundred years. We don't always know what we're seeing, but we take a really good educated guess at it. For instance, the star controller feature of this filter harnesses electrical grids. And as you can see the lines in here, you can see electrical pulsing in straight lines. And this is essentially another way of seeing how energy flows. So as I go through these filters showing you this, keep that in mind, that we're still on the cusp of learning. We're always learning something. And we don't always, get it right the first time. So I wanted to show you this particular filter. So this particular filter combines all of those filters you saw before into a multi-layered filter that can kind of Swiss Army knife the entire process. So you can go deeper at the same time and experience the look and feel of the energy as it wraps itself around objects and emits energy. And it may not look familiar to you. In some cases, you'll see things that go, whoa, that looks familiar. Because in our own world here on planet Earth, we have biology. We have cellular and quantum level physics happening all the time. When we breathe, when we bleed, when we eat, we're generating our own little power plants inside of our bodies. And when we look at our blood and we look at our cells under an electron microscope, we see life moving in a drop in a petri dish. And it's like a whole little world in that small gluons and muon level of magnification. And we just go, wow, this is amazing. Well, we have that same capability as humans to do that with the most powerful telescopes in the world. Now, until recently, our imaging hasn't been up to snuff. But with technology, we've been moving that imaging and focusing power forward. And if you've seen any of the new images from the new microscopes that are coming out, you'll see that we can now look inside molecules. We can discover and look inside bacteria, open it up, magnify it, and go through and see what the processes are happening. Now, this is what I had envisioned 30 years ago and what came to fruition 4 years ago. So now we're at a stage where we're actually making this happen. And hopefully more and more generations of our kids and their grandkids will continue to push forward in the field of science and take us to places we've never been before, just with our own eyes, being able to see deeper. So I'm going to show you where we're at. So I'm going to take this filter all the way down. Come on, little dude. We're going to take you down. So there's the original image, okay? And by adding this filter into this system, you're going to see what is actually inside. Now there's some areas here where you're going to see electricity pop up. I'm taking it down so you can see it moves pretty quick once it starts processing. And you can literally push through. So here we go. We're going to push through this and go deep, 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 deep. And I'm going to zoom in here so you can see it's still going. Oof. This thing is flying quick. You're going to see the electrical lines pop up. You're going to see flow happen. There they are right there. You're going to see things glowing. Again, things we've never seen before. But then, just when you think there's nothing left to see, you break through that next barrier of visibility. And there it is. Now, I tested this filter before I made this video. And when I was testing it for the first time on this particular image, I was blown away again when this center popped up. So inside where this item went supernova, we see three blue rotationary objects, and we see two dark black objects inside there. Let's keep going. Let's see how far it goes. This is the dead center of it all. And so for this particular filter, we would have to go even deeper. So we're kind of at a stopgap, is what I like to call it. And we'll back up here and we'll come back to it, because at this moment the filter itself is working and illuminating and finding all the stuff, because this is partially AI powered, and the instruction set within the masks of the filters give information to look for, and in some cases it's just generative to the point where, when I say generative, it sees the information and then shows you what it is, like that red circle up above, so that you can see what's in the photo. Let's see if I can get this thing to go a little farther. It seems to be stuck on a process. There it is. So for me, this is a very familiar shape. It's the shape of a star explosion when it blows out on both sides, and you've still got the spin in the center. You notice there's like 4 or 5 dots now around there. So there's objects spinning around so quickly, still going on inside this what appears to be an orb of energy. And the shape is mathematical. This is similar to like a torus. And one of the things that I want to do is get with some of the best astrophysicists and mathematicians out here to solve some of these, because all of this is solvable with math. Just like we've gotten this far, we can go farther. So when I say we go farther, we take this all the way into the center. And beyond this, we add to this filter. We continue looking deeper, going into it and picking out this color area and trying to find where the barrier breaks on the next frequency. And it's really a challenge sometimes. As we increase this, things just go black, or they'll come back and we get really close. But it's a matter of getting everything back and trying to figure out where the next stage of this piece is. It's not always easy, because sometimes it just stops and it's like a loop where you can't see beyond it until you see that square area right there? That's what I'm talking about, folks. There's these pieces that just talk to you. There's rotational boundaries from that. And see the item spinning inside that blue and yellow item up above there on the top left corner? See them spinning around? This is what was recorded in this particular image. These are the things I'm talking about. And it's hard to believe we missed it, but then again, we didn't learn to fly except for a couple hundred years ago in an airplane, so that this is how inventions are made. So, what do we do now? Well, we never touch the red, the green, or the blue. We don't need to. Isaac Newton said we only have to touch white. And within this white area of color of black and white bases, we can adjust and see where it goes. And sometimes it goes black, sometimes it goes completely white. But it's a matter of finding where the electrical values are within the image and opening them up, seeing where we can go to. And again, this is all from this image. So when you're looking at things, you're looking at it the inside of a photograph. But I wanted to go to the center of this, so that's why I chose to do it. So this gives you an idea of what I'm talking about when I work with dark light photos, and turning the photo into what you did, what you saw. These are hologramic type photos. They're not fake like a holograph. They're actual imagery with depth, and the camera took the picture. So all the information is there. It's a matter for us to get inside and find it, and this is what I'm talking about. My name is Kelly Swanson. I'm a citizen scientist. I hope you enjoyed watching. Have a good day.